Hi. So, retrieval roulette. You know the score by now. Pause, answer the questions, unpause whenever you're ready to mark. Okay, so here's our answers. So again, pause, get marking, correcting, filling in anything that you've left out, and then unpause, and we'll be ready to crack on with today's stuff. Right, last day we were doing questions 6 to 10 from these end of topic questions, so it was page 206 and 207. Let's just work through these and get them marked and corrected, please. So, question 6, calculate the weight, calculate the weight of an object of mass 70 kilograms on Earth. So for that we're going to use W equals mg. Substitute in our values, the mass was 70 kilograms, on Earth G is 10, so 700 newtons. Nice and straightforward for that one. B, the same object is taken to the moon where G is 1.6 meters per second squared. Calculate its weight on the moon. So it's the exact same calculation as above, except instead of 10 for G, we've got 1.6. So we get 112 newtons for that. Now, see, on another planet, a mass of 12 kilograms weighs 105.6 newtons. Calculate the value of G on this planet. So see here, all I've done is rearrange my W equals mg equation and made G be the subject. So whenever we do that, we're going to be dividing both sides by mass. So we end up with G, gravity, equals weight divided by mass. The weight was 105.6, the mass was 12, so we get 8.8 newtons per kilogram. And then D, comment on the units for G. Don't really know what it means by comment on, so I just listed them. So newtons per kilogram, or it can also be meters per second squared. Right, let's look at 7. So this is one of those things being fired up the way. A bullet is fired vertically upwards from a pistol from the surface of a planet. It rises to a maximum height of 1875 meters in a time of 25 seconds. Calculate the average velocity of the bullet during this time. Right, let me see. The average velocity is going to be the displacement divided by the time. So the displacement is 1875 and the time 25. So the average velocity there is 75 meters per second. Now, part B. Questions like this catch people out all the time. Using your answer to part A, which is the average velocity, or otherwise, calculate the maximum velocity of the bullet. Now, I'm just going to hide that here a wee second. You maybe already looked at it, but was this being a bullet being fired up the way? It's going to have its maximum velocity the second that it leaves the gun, and then it's going to decelerate all the way up. What was it, 1875 meters until the top where it's at 0. So do you know what we can use for that one? We can use that.
I found this on the web.
Stupid watch. We can use that average velocity is u plus v over 2 equation. Do you remember that? So that's the way I've done it here. I've said the average velocity of this bullet is its starting velocity plus its final velocity divided by 2. So we know the average velocity is 75. It's, oh look, I've put those the wrong way around. Oh, hold on. Should have been v plus 0, right? Because, no. Let me fix that. Sorry, I got all confused there. It should be u plus 0. I'll tell you why. So the starting velocity is going to be its like the highest velocity, and then it's going to decelerate until it reaches the top. So its final velocity is going to be 0, and that's being divided by 2. So that is it should be a u, right? So the starting velocity or the maximum velocity is going to be 75 multiplied by 2, which is where that 150 came from. Raging with myself, I've taken one of the ones that gets people confused the most, and I've made a stupid mistake in it, sorry. So I'll run through it again. Average velocity is starting velocity plus final velocity divided by 2. Average velocity is 75. Starting velocity is what we're being asked for, even though it hasn't said those words. It just asks for the maximum velocity, but the maximum velocity is at the very, very start. Final velocity up at the top is 0, and then that's being divided by 2. So multiply both sides by 2, and then you're just left with u equals 150. Okay, part C. The bullet then takes another 25 seconds to fall back to the planet's surface. Sketch a graph to show how the velocity of the bullet changes during the entire motion. So here's mine here. Oh, spoiler. So it started off at a velocity of 150. After those 25 seconds, it had reached the, haven't labelled my axes. It had reached its maximum height where the velocity was 0, and then it accelerated back down after another 25 seconds, so at a time of 50, and its velocity is going to be minus 150 then, because it's 150 in the opposite direction. So straight line. This is very like that example that we did, was it 2 lessons ago now? Do you know what I mean? The example that came just before these questions in your notes. Okay, D. What is the average velocity of the bullet over the entire distance covered? Well, you can see my answer there is 0. And the reason for that is because the total displacement is 0. It ends up back where it started. So if you think about the average velocity is the total displacement divided by the total time. Well, its displacement is 0. So if you divide that by any number, you're going to end up with 0. So because it's ended up back where it started, its displacement is 0, which means its average velocity is 0. And then F, use your sketch to determine the acceleration due to gravity on this planet. So the you can't see it. The acceleration is the gradient. So I've just taken the gradient from here to here. I know it really should be a negative, but for the value of gravity, the negative doesn't matter. So the rise over run method, if I'm using these 2 points, then my difference in the y is 150, difference in the x is 25, so 6 meters per second squared for that. Okay, let's do the next ones. So question 8 is about this boat. It has a mass of 15,000 kilograms, has a forward force acting here, and then the force of friction is 12,000 newtons, and we can just about see there its acceleration is 2 meters per second squared. Oh, it tells us that anyway. So the force on the friction on the boat is 12,000 newtons, and it's accelerating at 2 meters per second squared. Calculate the resultant force on the boat. So F equals ma. The mass is 15,000, acceleration is 2, so the resultant force is 30,000 newtons, right? So that means the overall force acting this way, pointing in this direction, is 30,000 newtons. Then part B is asking us to get the forward force from the boat's engines. So I didn't draw a wee diagram here, but what I'm doing here is saying that the overall effect of these forces is 30,000. So we have our forward force, let's call that F, from our engines, and then we have our 12,000 going that way. So it's because it's accelerating this way, the resultant force is going to be F minus 12,000. So we need to add that 12,000 onto both sides. Hold on a second. Oh, this is just full of mistakes, this, isn't it? And we get 42,000 newtons. Sorry. So we add 12,000 onto both sides, 42,000 newtons. So let's think it through again. If we have 42,000 newtons going this way, 12,000 newtons going that way, then the combined effect... I didn't catch that. The combined effect of those is going to be the 30,000 to the right, because it'll be the 42,000 minus the 12,000. Oh, what a disaster. Right, 9. An object falls from rest and strikes the ground exactly 1.5 seconds later. So here's my information. U is 0. Because it's accelerating down towards the ground, its acceleration is 10 meters per second squared. Time, 1.5 seconds. Part A, at what speed does it hit the ground? So we're looking for the final velocity, V. So I've just used A equals V minus U over T, or do you know what I could have done? V equals U plus AT might have been easier here. In fact, do you know what? I'll do it out that way here. So V equals U plus AT. I know it's the same equation, but there's less rearranging to do with this version. So V equals 0 plus 10 multiplied by 1.5. So V equals 15 meters per second. Yeah, it's definitely easier, isn't it? But there you go. There's both ways. Part B. A ball is thrown vertically upwards with an initial speed of 24 meters per second. Part 1. How long does it take the ball to reach maximum height? So U is 24 meters per second up the way. At its maximum height, its speed is going to be 0. So its acceleration is going to be minus 10, because it's going to be accelerating down the way or decelerating up the way. And we have to find the time. So same again, I would just use A equals V minus U over T, or again V equals U plus AT. Will I do it out again? Yeah. So V equals U plus AT. V is 0, U 24 minus 10t. Add 10t to both sides. Divide by 10. 2.4 seconds. So there you go. There's both different methods. Now, part 2. What is the maximum height? I have done this out on here the way that I would do it if I didn't know the equations of motion. So I can take you through doing the equations of motion way afterwards. So see here, I've used the fact that the distance travelled is going to be the average speed multiplied by the time. But to use that, I need to figure out what my average speed is. So we know it hit the ground at 24 and it started at 0. Wasn't this thing that was dropped, wasn't it? No, it's being thrown up, sorry. So it was thrown up at 24 and then it was 0 up at the top. So the average speed for the journey, if we do the average speed is u plus v over 2 equation, 24 plus 0 divided by 2 is 12 meters per second. Don't know what was wrong with me the day I did these. So average speed 12 and the time was 2.4. So that gets us our height of 28.8 meters. However, see this here? This is one of the types of questions that I see answered incorrectly the most often, right? And it's because of that we do teach you the equations of motion. So see if I was to go, let me get a wee spare bit of paper. Right, so I'm going to try and answer B part 2 as if I'd already done B part 1, okay? I'm going to use my same list here. So this thing's thrown up at 24 meters per second. Its final velocity is 0 because we're only looking at the part of the journey up until the top. Acceleration is going to be minus 10. We're being asked for the maximum height and we have just figured out that the time it took was 2.4 seconds. So instead of doing this method here, we could do, or we could use one of the equations of motion. So say if I wanted to avoid using t, I would probably use v squared equals u squared plus 2as. So v is 0, u 24 plus 2 multiplied by minus 10 multiplied by s. So what's 24 squared? 576 minus 20s. Add 20s to both sides and then divide by 20. And we get 28.8 meters. So we get the same answer there. So either method works. Either method is as valid as the other. There's no better way. It's up to you, whichever you prefer. Okay, so you can either do this or you can figure out the average speed for the whole journey and then use distance equals average speed times time. Remember, you cannot just do distance equals speed times time and plug in that 24 because that would calculate the distance as if it was travelling at 24 meters per second the whole time, and it's not. It's slowing down from 24 meters per second to 0 on the way up. Right, question 10. The friction force opposing the motion of a locomotive of mass 25,000 kilograms is 100,000 newtons. What forward force must the locomotive provide if it is to travel along a straight horizontal track at a steady speed of 1.5? Well, if it's going at a steady speed, then the forces on it have to be balanced. So let's say it's going this way, right? We were told that the frictional forces were 100,000. So the forward force must also be 100,000. Oh, I've lost count of my zero, is that right? Yeah. The forward force has to be 100,000 as well. If it's going at a steady speed, forces are balanced. So there's my answer there, 100,000. B. What is the acceleration of the locomotive if the forward force increases to 175,000 and the friction force is unchanged? So here's my wee diagram. Forward force is now 175,000. Frictional force is 100,000. So you can either do it all in one go like I have done here, or you can work out the resultant force separately. So we're going to be using F equals ma. The resultant force is the F in F equals ma. So it's going to be the forward force minus the frictional forces. Mass was 25,000. So tidying up from this line to this line, this, take away this, gives you 75,000 equals 25,000a. Divide by 25,000 and you get the acceleration to be 3. Now, we're actually ready to start our new topic, but I'd rather just wait and start. It's Hooke's Law is next. I'd rather just do like a proper lesson on Hooke's Law next day, so which I think is tomorrow. So what I'm going to do here is also link Mr. Ross's videos where he's going over all of these questions, because you might find that he has either done a question slightly differently than me, or he has just explained it slightly differently, and you might prefer his method. Okay, so watch Mr. Ross's videos as well, it'll do no harm. And then with the rest of the time, if you do some self-quizzing, please, from your knowledge organiser and your self-quizzing booklet, okay? Just to make sure we're on top of all our key facts. Okay, I will see you next day.